Hello everyone and welcome to the lecture on Amazon CloudFront. So this lecture will contain all these topics. What is Amazon CloudFront? How you configure CloudFront to deliver your content, use cases, how CloudFront delivers content to your users, regional edge caches, overview of CloudFront distributions, customizing CloudFront with policies, protecting CloudFront with AWS Web Application Firewall, using HTTPS with CloudFront, and customizing CloudFront with edge functions. So first one, what is Amazon CloudFront? CloudFront accelerates the delivery of various web content types including .html, .css, .js and image files, ensuring faster access for users. CloudFront leverages a worldwide network of data centers called edge locations to deliver content efficiently. When a user requests content served by CloudFront, the request is routed to the edge location that offers the lowest latency, ensuring the best possible performance. If the requested content is already cached in the edge location with lowest latency, CloudFront delivers it to the user immediately. If the content is not cached in the edge location, CloudFront retrieves it from the defined origin, such as an Amazon S3 bucket, media packet channel, or an HTTP server. CloudFront routes user requests through AWS backbone network to the edge location that can best serve the content, dramatically reducing the number of networks the request must pass through and improve performance. By caching copies of files, which are known as objects, in multiple edge locations worldwide, CloudFront increases reliability and availability of the content. So how you configure CloudFront to deliver your content? 1. You specify origin servers like an Amazon S3 bucket or your own HTTP server from which CloudFront gets your files, which will then be distributed from CloudFront edge locations all over the world. An origin server stores the original definitive version of your objects. If you are serving content over HTTP, your origin server is either an Amazon S3 bucket or an HTTP server such as a web server. Your HTTP server can run on an Amazon Elastic Compute Cloud EC2 instance or on a server that you manage. These servers are also known as custom origins. You upload your files to origin servers. Your files, also known as objects, typically include web pages, images and media files, but can be anything that can be served over HTTP. If you are using Amazon S3 bucket as an origin server, you can make the objects in your bucket publicly readable so that anyone who knows the CloudFront URLs for your objects can access them. You also have the option of keeping objects private and controlling who accesses them. You create CloudFront distribution, which tells CloudFront which origin servers to get your files from when user requests the files through your website or application. At the same time, you specify details such as whether you want CloudFront to log all requests and whether you want the distribution to be enabled as soon as it is created. CloudFront assigns a domain name to your new distribution that you can see in the CloudFront console, or that is returned in the response to a programmatic request, for example an API request. If you like, you can add an alternate domain name to use instead also. CloudFront sends your distribution's configuration but not your content to all of its edge locations or points of presence known as POPs, which are collections of servers in geographically dispersed data center where CloudFront serves from. Okay, some use cases of CloudFront. 1. CloudFront can speed up the delivery of your static content, for example images, style sheets, JavaScript and others HTML related files, to viewers across the globe. By using CloudFront, you take advantage of AWS backbone network and CloudFront edge servers. CloudFront offers several options for streaming your media to global viewers, both pre-recorded files and live events. For video on demand VOD streaming, you can use CloudFront to stream in common formats such as MPEG Dash, Apple HLS, Microsoft Smooth Streaming, and CMAF to any device. For broadcasting a live stream, you can cache media fragments at the edge so that multiple requests for the manifest file that delivers the fragments in the right order can be combined to reduce the load on your origin server. When you configure HTTPS with CloudFront, you already have secure end-to-end connections to origin servers, and when you add field level encryption, you can protect sensitive specific data throughout system processing in addition to HTTPS securely, so that only certain applications at your origin can see the data. Okay, how CloudFront delivers content to your users. So first, after you have CloudFront to deliver your content, so let's say a user accesses your website or application and sends a request for an object such as an image file or an HTML file. So it goes to they enter in the browser. Then next, our DNS routes the request to the CloudFront POP edge location, which are called as points of presence location, that can best serve the request, typically nearest CloudFront POP in terms of latency. So it will know which one is the nearest. And then CloudFront checks its cache for the requested object. So it checks here. If the object is in cache, the CloudFront returns it to the user immediately. If the object is not in cache, let's say this is the first time it's happening, the CloudFront does the following. The CloudFront compares the request with the specifications in your distribution and forwards the request to your origin server for corresponding object. So let's say, for example, to your Amazon S3 bucket or your HTTP server. So let's say you have here or here, one of the places. The origin server sends the object back to the edge location, and as soon as the first byte arrives from the origin here, from here to here, CloudFront begins to forward the object to the user. CloudFront also adds the object to the cache, so it will, as soon as the byte arrives, it will start sending and it will start caching for the next time if someone requests. So it will be here for the second user or the second request. Okay, this is regional edge caches. Okay, so regional edge caches are CloudFront locations that are deployed globally close to your viewers. So we are talking about here regional edge caches. They are located between your origin server over here and edge locations, which are called as points of presence. As objects become less popular, individual POPs, edge locations, might remove these objects to make room for more popular content. So this is have less space. This is bigger object, and this has less memory or less space. So this will get evicted from here sooner than over here. So regional edge caches have a larger cache than individual POP. So the object remain in the cache longer at the regional cache location, and this helps keep more of your content closer to your viewers, reducing the need for CloudFront to go back to your origin server. So this is origin server S3 or HTTP server. When a viewer makes a request to your website through your application, DNS routes to the, as I talked about, to the POP, and the location is typically the nearest. And in the POP, CloudFront checks its cache. If it's not in the cache, it will retrieve from here. So this is we are going in depth. So there are two components of which makes the global infrastructure of CloudFront. And CloudFront also adds the object to the cache in the POP for the next time. So it will just add here, both the places. And after your origin server sends the request back to the regional edge location, it is forwarded to the POP. So again, same flow. Yeah. Okay, next I'll talk about overview of distribution. So what are CloudFront distributions? So this is the main object within CloudFront when you configure. So you create an Amazon CloudFront distribution to tell CloudFront from where you want content to be delivered, and the details about how to track and manage the content delivery. So your content origin, the Amazon S3 bucket, AWS Elemental Media Package Channel, AWS Elemental Media Store Container, Elastic Load Balancing Load Balancer, or HTTP server from which CloudFront gets the files to distribute. You can specify any combination of up to 25 origins for a single distribution. So it can have 25 origins for a single distribution object that you create. 3. Access. So whether you want access to the files to be available to everyone or restricted to some users. So you can have access control there. Talking about security, whether you want to enable AWS Web Application Firewall WAF protection and require users to use HTTPS to access your content. Cache key. So this one is which values if you want to include in the cache key. The cache key uniquely identifies each file in the cache for a given distribution. Then origin request settings. So this settings allows you control whether you want CloudFront to include HTTP headers, cookies, or query strings in the request that it sends to your origin. Then some geographic restrictions, whether you want CloudFront to prevent users in selected countries from accessing your content. Okay, customizing CloudFront with policies. CloudFront cache policy allows you to specify HTTP headers, cookies, and query strings that determine the cache key. Fewer values in the cache key increases the likelihood of a cache hit. You can also set TTL, time to live, for cached objects and enable caching of compressed objects. An origin request policy lets you specify HTTP headers, cookies, and query strings to include in request sent to the origin during a cache miss. This allows including additional values in origin request without affecting the cache key. And a response headers policies enable you to control HTTP headers in response sent to viewers. You can remove headers from the origin's response or add headers to CloudFront response without modifying the origin or writing code. Okay, next is protecting CloudFront with AWS WAF. So AWS WAF is a web application firewall that secures web applications and APIs by blocking requests before they reach the servers, protecting CloudFront distributions and origin servers. One-click protection creates an AWS WAF web access control list, web ACL, and this configures rules to protect servers from common web threats and attaches the web ACL to CloudFront distributions automatically. Users can also enable AWS WAF protections by creating a pre-configured web ACL in the WAF console or using WAF APIs. AWS WAF can be enabled when creating a new CloudFront distribution or by modifying the security settings of an existing distribution. When using one-click protection, CloudFront applies an AWS recommended set of protections that block IP addresses from potential threats based on Amazon's internal threat intelligence. One-click protection also defend against the most common vulnerabilities found in web applications, such as those described in Open Web Application Security Project Top 10 list. The AWS recommended protection also help against malicious actors attempting to discover application vulnerabilities when one-click protection is enabled. Okay, using HTTPS with CloudFront. So the process begins with the viewer submitting an HTTPS request to CloudFront, and this initiates an SSL TLS negotiation between the viewer and CloudFront to establish a secure connection. During the SSL TLS negotiation, the viewer and CloudFront exchange necessary information to establish a secure encrypted communication channel. Once the negotiation is complete, viewer submits the request to CloudFront in an encrypted format. If the requested content is already cached at the nearest CloudFront edge location, CloudFront encrypts the cached response and sends it back to the viewer. The viewer then decrypts the response to access the content. If the requested content is not cached at the edge location, then CloudFront initiates another SSL TLS negotiation, this time with the origin server. Once the negotiation is complete, CloudFront forwards the encrypted request to the origin server. The origin server decrypts the request, processes it, generates a response, encrypts the response, and sends it back to the CloudFront. Upon receiving the encrypted response from the origin, CloudFront decrypts it, re-encrypts it, and forwards the response to the viewer. This ensures that the content remains secure throughout the entire delivery process. In addition to forwarding the response to the viewer, CloudFront also caches the response at the edge location. This allows future requests for the same content to be served directly from the cache improving performance and reducing the load on the origin server. Okay, customizing CloudFront with edge functions. With CloudFront, you can write your own code to customize how your CloudFront distributions handle HTTP requests and responses, which allows for powerful customization options. The custom code, called an edge function, runs close to your viewers to minimize latency. You don't have to manage any servers or infrastructure. You can write code to manipulate the requests and responses that flow through CloudFront, perform basic authentication and authorization, and even generate HTTP responses at the edge. Edge functions enable you to implement basic authentication and authorization mechanisms to secure access to your content and resources. CloudFront functions for lightweight, high scale, latency sensitive customization using JavaScript, and Lambda for edge for more complex functions and application logic using Node.js, Python with automatic global replication. Basically, there are two options. One is CloudFront functions, which is lightweight and high scale. But if you want more complexity and application logic, you can use something called as a feature called Lambda at edge, and which offers you write code in Node.js or Python, and this has automatic global replication. So you write once Lambda at edge, and it will distribute across all the points of presence or the edge locations across the globe. And that's all. Thanks for watching.